Drip would be the other system to look at. And drip, we can get 95% plus efficiencies because we are point applying that water exactly where we want it. And so every drop is being used by the crop that we're trying to water with. So we have tremendous potential with drip to get really high efficiencies. And that's why there's an awful lot of interest in drip. Because boy, we can use every drop of water we're pumping, we're trying to use it, and we can come close. One area we haven't hit here, we talked about seasonal irrigation requirement, and we developed the structure for the net seasonal irrigation requirement. Now, to get the seasonal irrigation requirement, we have to take that net and simply divide it by the efficiency of our system. So we know how much the crop needs, then we have to divide by the efficiency of the system because we're going to lose a certain amount of water due to that efficiency. So here again we have the net irrigation requirement divided by the system efficiency. That will equal the seasonal irrigation, the gross seasonal irrigation requirement. The total amount of water we're going to need to apply is going to be the net divided by the efficiency. So this efficiency is going to be it's going to be in a percentage. So if we had a system, a turf system that's 80% efficient, this efficiency would be 0.8. So if we needed 30 inches of water, we divide it by 0.8 to get the actual total amount of inches that we needed. So for example, we could say we needed 30 inches for turf. Our system efficiency was 80%, 0.8. We would get a value
37.5.
Okay. So we really need to irrigate 37.5 inches. The crop only needs 30, but we got to put down that much because we're 7.5 inches inefficient over the season. We just can't do it perfect. And you know, I haven't met a perfect irrigation system yet. They don't exist.
I haven't seen one either. That's why we paid for this class.
That's right. We're going to, one of you guys may come up with that perfect irrigation system. Now, there's another aspect we have to be concerned about, and that is the peak irrigation requirement. The peak is obviously going to happen during the hottest part of the year. So now we have to design the capacity of the system to be able to handle the hottest part of the year. We don't design it for an average over 12 months, obviously. In most places there's 6 months we never irrigate. Some we don't average it over the 6 months we irrigate. It'd be pound foolish to put on the same amount of water in April that we put on in July per time. I mean, it would be senseless. We don't use that much water in April, and we use way more in July. So we're going to have to find out when the worst part of the season is, find that peak, and generally we look at the peak month. Some people even go down and pick the peak 10 days or 14 days and design the system to be able to handle the replenishment for those very critical days that will happen in the hottest part of the summer. So we do have to, when we're designing the system, look at the total demand as far as a peak demand over a period of time of reasonable length that we have to make sure we can continue to maintain quality within our crop. Now we have, then we can figure out, if we know what that length of time is, we can find the net amount of water we need to apply during, instead of a season, during, say, a 10-day period of time. We're going to look at the worst period of time get the average for that 10-day period of time, and we know how much we need to put on over that 10 days. Simply divide it by its efficiency, and we know what our gross water demand is going to be over those 10 days. Then we have to size that system to be able to handle it, just like I talked about with the cherries. We didn't look at how much the cherries used in April. We looked at how much the cherries used in July. And that was our determining factor. We knew they needed so many gallons of tree a day, so we were in a position to make a judgment off of that peak demand time at its most highest consumptive use rate. And we took a block of 10 days, which is a pretty typical average to average over. Now you could go into weather records and look for a spike, you know, the very worst day on record. And you say, well, the very peak would be. Now if you're growing bent grass on the most prestigious golf course in the Pacific Northwest, and that course happens to be in the middle of the desert out here, you may want to know what that one spike peak day is, because you must conform to the very worst condition with that bent grass green, otherwise you're going to have some disasters occur out there. So there are times when you need to know the very worst possible condition with some extremely tedious crops. Now the nice thing about a golf course is you can steal water from the roughs for a day, let them dry up a little bit, and give it to the greens. But if you had 100 acres of bent grass, you wouldn't be able to do that. So then you'd have to look at the spike and say, God, we're going to have to be able to cover the very worst condition ever, which is going to really size up your system, because that day may be a 20% greater demand than your average 10-day block that you're watering to. Getting the idea? It's all a deal of trying to maintain a constant growth and trying to find out a size of system that's economical, yet will continue to provide quality and quantity of the product we're growing.